Number 46. Calculate the atomic weight of antimony, which has two isotopes with the following properties. Antimony 121, its mass is 120.90 AMU, atomic mass units, and 57.21% natural occurrence. And antimony 123, its mass is 122.90 atomic mass units, and natural occurrence 42.79%. Okay, it's asking us to calculate the atomic weight. What this is really talking about is if you have a pile of antimony. So here I'll just draw a little pile of antimony. Okay, there are two types of antimony atoms. You got antimony 121 atoms, which weigh this much. And then you got antimony 123 atoms, which are a little bit heavier. They weigh that much. So randomly dispersed throughout this pile of antimony atoms, you can imagine, some of them are the 121 isotope. 57% of them are the 121 type. And the other 42% or 42.79% are the 123 isotopes, maybe a tad bit less are 123, and they're all evenly mixed. So any pile of antimony, you're going to have the two different types of isotopes. Now when it says to calculate the atomic weight, it's asking us for what's the mass of the average antimony atom. Some of them are this type of atom, and some of them are that type of atom, and you know how much of each type you got, and you know how much the both of them weigh. So how do you calculate the mass of the average antimony atom? That's the atomic weight. Okay, the equation that you use is right here. To calculate the atomic weight, you take the fraction, which is isotope number 1, and multiply it by its mass, and then you add the fraction, which is isotope 2, times its mass. Now we're given the two masses of the isotopes, so we can directly plug those in. So let's plug in the mass of isotope number 1. That's antimony. Let's just say this is the 121, and that's the 123 that we're talking about. So the mass of the 121 isotope is 120.90 AMU, and then the 123 isotope weighs 122.90 AMU. Okay, we have to multiply those masses by the fractions, okay, and then we add them together. So what's the fractions? Well, you can convert percentage to fraction by moving the decimal point over two places. So 57.21% is going to be 0.5721, and then 42.79% is 0.4279. And there we go. So let's calculate this. So we do this multiplication to get the result here. Let me break out the calculator. Here it is. So 0.5721 times 120.90. And that's going to give us 69.16689. So 69.16689. Now that should be rounded right there, because you got 4 sig figs, 5 sig figs. So you can round to 4, but we'll keep these extra digits because we still got to, add this part. You never want to round until the very, very end. So let's do this. That's going to be 0.4279 times 122.90, and that's going to be 52.58891. So here I'll line these up. Plus 52.58891 0.891. This would be rounded right there too. And so you can see from the sig fig rules that you should round right there. But let's go ahead and add everything up. So you take this number and you add that number, and you get 121.7558. So 121.7558. And since we round to this position, that's going to round up to 121.76. 121.76 AMU. That's the atomic mass of antimony. Let's just verify that on the periodic table. So here's the periodic table. Antimony is right there, element 51. Okay, and you can see its atomic mass, 121.76, and we just calculated it.